Hi, and this is my science fair entry, minerals, crystals, and gems. Oh my! My question was, how can I identify a variety of rocks, gems, and crystals? I'd been collecting rocks, gems, and crystals since we took a family trip to the Herkimer Diamond Mine in New York, but I don't know what they all are. I want to figure out what types of rocks I have so I can categorize and label them. For this experiment, I will take 10 rocks of various size, shape, weight, and color and see if I can perform scientific experiments to figure out what they are. My hypothesis was that I can accurately identify rocks, gems, and crystals by inspecting their individual properties in these 6 tests. Luster, or how light reflects off the specimen, volume, or how much space each specimen takes up, weight, or how much each specimen weighs, specific gravity, or the calculated relative density of a rock, UV light reaction, or if it changes color under a black light, crystal form, or the type of crystal structure the specimen has, and scratch test, or how high the specimen is on the Mohs hardness scale. Then I can use the information I've collected and look through 4 different rock, gem, and crystal identification books to see if I can match my results to a specific rock, gem, or crystal. My materials were 10 rocks, crystals, and gems, 10 white unglazed tiles, a graduated cylinder, a long wave UV light, which is purple, a scale, glass, a calculator, labels, a Mohs hardness chart, a stainless steel knife, and 4 books: Minerals, Rocks, and Gems, Minerals and Gemstones, the Encyclopedia of Crystals, and Rocks, Gems, and Rocks, Minerals, and Fossils of the World. My procedure for determining the type of rock, gem, or crystal of each specimen is to categorize the luster as metallic, adamantine, vitreous, resinous, greasy, pearly, shining, semi-metallic, dull, silky, waxy, or glassy. Measure and record the weight, the volume in milliliters, and calculate the specific gravity, calculated by the weight and volume. To test each specimen to find if rock glows under a long wave purple UV light, to find the crystal form or the structure of the rock, and to perform a scratch test to determine where the specimen is on the Mohs hardness scale. I would then cross-reference my findings with 1 or more of my reference books to determine the type of rock, crystal, or gem each specimen is. I would then compile the results into graphs. These are 10 of the types of luster, and you can see that adamantine and greasy are really different. There are then 8 crystal formations that I can identify my rocks to: trigonal, monoclinic, tetragonal, amorphous, hexagonal, cubic, orthorhombic, and triclinic. My first specimen is sodalite. I identified the luster as greasy. The specific gravity is 2.47. The volume is 30 milliliters. The weight is 74.3 grams. It glows orange under the UV light. Its crystal form is cubic. And the scratch test shows that it is 5.5 to 6 on the Mohs hardness scale. My second specimen is amethyst. I identified the luster as adamantine. The specific gravity is 0.71. Volume is 10 milliliters. The weight is 7.1 grams. It doesn't react under UV light. Its crystal form is classic quartz shape or hexagonal. And the scratch test shows that it is 7 on the Mohs hardness scale. My third specimen is kyanite. I identified the luster as adamantine or greasy. The specific gravity is 2.22. The volume is 15 milliliters. The weight is 33.3 grams. It doesn't react into the UV light. The crystal form is triclinic, and the scratch test shows that it is 4.5 to 7 on the Mohs hardness scale. My fourth specimen is fluorite. I identified the luster as greasy or dull. The specific gravity is 2.89. The volume is 20 milliliters. The weight is 57.8 grams. It doesn't react under the UV light. The crystal form is cubic, and the scratch test shows that it is 4 on the Mohs hardness scale. My fifth specimen is turquoise. The luster is metallic. The specific gravity is 1.76. The volume is 5 milliliters. The weight is 8.8 grams. It doesn't react under the UV light. Its crystal form is triclinic, and the scratch test shows that it is 5 to 6 on the Mohs hardness scale. My sixth specimen is mica and unknown. I identified the luster as dull. The specific gravity is 6.55. The volume is 1 to 3 milliliters. The weight is 13.1 grams. It doesn't react under UV light. Its crystal form is hexagonal, and the scratch test shows that it is 2.5 to 4 on the Mohs hardness scale. My seventh specimen is black obsidian. I identified the luster as metallic. The specific gravity is 1.23. The volume is 10 milliliters. The weight is 12.3 grams. It doesn't react under the UV light. Its crystal form is smooth and uniform. And the scratch test shows that it is 5 to 5.5 on the Mohs hardness scale. My eighth specimen is celestebarite. I identified the luster as greasy. The specific gravity is 2.74. The volume is 20 milliliters. The weight is 54.8 grams. It doesn't react under the UV light. Its crystal form is orthorhombic, and the scratch test shows that it is 9 on the Mohs hardness scale. My ninth specimen is tiger's eye. I identified the luster as metallic. The specific gravity is 2.485. The volume is 20 milliliters. The weight is 49.7 grams. It doesn't react under the UV light. Its crystal form is hexagonal, and the scratch test shows that it is 6.5 to 7 on the Mohs hardness scale. My 10th and last specimen is corundum, or ruby. I identified the luster as greasy. The specific gravity is 3.1. The volume is 1 milliliter. The weight is 3.1 grams. The UV light, it reacts red under the UV light. Its crystal form is hexagonal or rectangular, and the scratch test shows that it is 9 on the Mohs hardness scale. My first chart is luster. The dark blue is my first classification, the gray is my second classification, and the orange is the actual luster. My next graph is specific gravity. The light blue is the calculated specific gravity, and the dark blue is the reference gravity. My third chart is the Mohs hardness scale. It compares all of my crystals, rocks, and gems, and you can see that the majority ranges from 2 to 7 on the Mohs hardness scale. My last chart is the crystal form. The light blue is the first classification, and the dark blue is the second classification. This is the long-wave UV light reaction for my sodalite and the corundum. For the sodalite, it's a blue and white stone, but it glows orange under a UV light. For the corundum, it's a brown-black stone, but it glows red under the UV light. Shortwave UV light looks white, medium-wave UV light looks light purple, and long-wave UV light is purple. Bonus: phosphorins. If you shine a shortwave UV light on a phosphorescent specimen, the rock will glow and continue to glow for 1 to 2 seconds after it's turned off. Ask the expert Michael Duck. I had the privilege of speaking with a rock expert, and here's some very interesting pieces of information I learned. The first thing you want to do is figure out if the rock is sedimentary, metamorphic, or igneous. If you look up silicon dioxide, you'll find out that 78% of Earth's crust is quartz. Occurrence is important, and certain minerals appear together. Matrix is the base mineral that mineral sits in, and there are geodes big enough that you could drive a car into them. My conclusion is, based on the results of my findings and the information found in the reference books, I believe more research is necessary to correctly identify all of the specimens. While I was able to correctly identify many of the specimens, I was not able to confirm positive identity for them all. Further research is necessary to determine mixed samples, which is common for random samples. I should also have additional tools such as different UV lights. However, I'm on my way to become an authentic rockhound, and with a few more years of experience, additional research, and more exposure to a larger variety of samples, I'm sure identifying them will become second nature. And I'm sure asking additional questions of Michael Duck or other rock experts, I'll be able to learn some more secrets to unlocking the identify some cool rocks. My 4 references are book number 1, Minerals and Gemstones. Book number 2, Minerals, Rocks, and Gems. My 3rd one is the Encyclopedia of Crystals. And my 4th one is Rocks, Minerals, and Fossils of the World. I also have a link for the most hardness scale chart and mineral info PDF. This is my presentation, Minerals, Crystals, and Gems, oh my.